Hey guys, it's Casey and welcome back for part 3 of our tower defense tutorial. So in part 1, we set up our AI. If we go to our AI folder, we set up our AI, we have it spawn, and we have it run along the outside of our arena here. And then in part 2, we set up the basics for our tower and our projectile so that now we have a tower in the world so that we can target our runners and we can shoot at them and we can deal some damage and destroy them. So let's hit play real quick and let's just see what we've done so far. Our runner runs inside, we spawn a projectile, we shoot at them, and we destroy them. Great. So what we're going to do now is we are going to go in a bit more depth with our tower and our projectile. Or at least we're definitely going to get more in depth with the tower. We'll see about the projectile. We might put that to another episode. But for now, let's open up our tower. So we have this acting as a very, very, very basic set of logic, right? If we spawn 10 runners, our tower would instantly shoot all 10 of them. Also, if, say, we didn't instantly kill our enemies, this only shoots once. This isn't constantly shooting our targets. So what we're going to end up doing is we're going to go a bit more in depth and we're going to expand on this logic. But before we really get there, let's take one step back. So what we can do is that we are now going to map out kind of everything that our towers are going to handle, or all the variables that our tower is going to handle. So what I'm going to do is that we want to use data tables. And a data table is a very, very clean and easy way of basically creating a huge list of predetermined data. And what we're going to put inside of that is data relating to our towers. So to do that, the first thing we would need to do is that we need to make a structure to handle our data table. So if we right click and we go under blueprints, we have something here called a user defined struct. So if we click that, and we will name this our tower struct, and if we open it up, if you've never used structs, they're pretty cool. What it basically is that it is going to be it's called a struct because basically it's a structure of variables. So what we can do inside of it is that we can add a bunch of variables. We can make them whatever we want. We could create some strings, some vectors. We could put basically any type of variable inside of this, and now what we can end up doing is that if we go inside of our tower, what we can do is we can create a variable. We can call this our tower struct, and then what we can do is we can change the variable type now to be, hey look, we have tower struct. And that what we can now do is that if we grab our tower struct and we get it, it's blue because it is a user-defined struct, and that if we break it, you can see here that all of a sudden it has all these variables that I just randomly punched in here. So that's what we're going to use this for, is that it's a very clean and a pretty good way of storing grouped data is how I would kind of think of it. For a final version of a game, I am kind of careful about how much I use structs. There are good situations and there are bad situations for using structs. I would lean towards, if you are a beginner, to liberally use structs if you feel like they are useful, and then later on down the road you might find there's some better alternatives for certain situations instead of using structs. But for beginner purposes, I'm a really big fan of them. It helps keep your code very clean. So what we're going to do is we're going to go back to our struct, and now I'm going to delete all these extra variables I made. So we're going to kind of think through everything that represents our towers. What's going to be unique about our towers? So the first thing I'm going to do is I'm going to create one called name, because I want to have a name for our towers. We need to be able to identify each individual tower. Let's make another variable. We'll make it a float, and this will be the damage of our tower. Let's do another one, another float, and let's do the range of our tower. That can be unique. That can change. How about the fire rate of our tower? So let's do, we'll call it fire rate. And then we'll keep that as a float also. So we have damage, we have range, we have fire rate. What's some other things that we can make? How about the mesh of our tower? We could do that. So we can say mesh, and that now we can go into here and we can type in static mesh, and we can find static mesh and an actor. Let's actually look real quick. So if we go inside of our tower, what is this necessarily? It's a static mesh component. So let's actually look. If we type in static again, that's what we need, static mesh component. Ooh, why is that disappearing? Let's try that one more time. Static mesh component. There we go. Static mesh component. So let's do that one instead, because what we really want to do is we want to exactly set the static mesh inside of here. And if I highlight it, it's kind of weird. I'm not exactly sure what the reasoning is, but you can see that's called a static mesh component, and that if we type static again, you can see we have static mesh actor, static mesh component. I'm not really sure why they separate them that much, but we'll not really worry about that too much. If we need to change this to be a static mesh actor, it's really as simple as coming back inside of this struct and just doing the drop down and changing it real quick. So we have our mesh. Let's see here. We can store, what else do we want to store inside of here? I think this might be good to start. And once again, whenever we want to add more to this, all we have to do is open back up our struct, hit new variable, type it in, and it automatically updates our struct. There's no breakage. There's nothing that's going to go wrong for us. So this is a really cool way of doing it, and you don't have to finish it all at once. We can always come back. So with our struct made, now we're going to make a data table. So this is pretty cool in my opinion. And that if we right click, you can go under, I believe it's under miscellaneous and data table. So it's under, if you right click and go under miscellaneous data table, and it's called imported spreadsheet table because this behaves a lot like a spreadsheet. And I'll actually show you something in a little bit that you can do. But first we want to create the data table, and it's going to ask us to pick a structure. That's why we made the struct here. It's because to make a data table, we have to have a defined struct. Now we can do the drop down and we can grab our tower struct. And if we hit OK, it's going to create the data table, and let's call this tower. Ah, it did it again. The auto saves. Let's call this tower data table. Now if we open up our data table, you'll see it has columns for the structure we made. So what we need to do is now we need to add rows. If you've ever worked in something like Excel, this behaves a lot like Excel, and that's for a very good reason, in that if we actually opened up an Excel file and we structured our Excel file to match the format of our structure, what we could actually do is we could drag that Excel file from like our desktop, we can drop it into Unreal, and then it's going to say, hey, what do you want to do with this Excel file? And we can say we want to make this a data table. You select which data table you want, and then we could populate any of these data tables with Excel files. So it's actually pretty cool that if you're handling a large amounts of data, which I have done that for some of my games, where I've had data tables with, I think it was almost 20,000 rows. It was just super easy for me to do all my work, spend a few days in Excel doing my thing, and then I can come back, drag and drop it in Unreal, and it's good to go. So if you're dealing with a bunch of data, you can pretty much kind of link Excel files to your Unreal. It's pretty cool. So what we did here is that, let me delete this. All I did here is that I hit this plus button, and that's add a new row. So when we add a new row, by default, I believe its name is just going to be called new row. So what's going to be the first name of our tower? Let's call it our bush. So we're going to make this like our bush tower. So we'll call it bush, and then I'm going to duplicate the name here and type bush again. This is something I tend to do with data tables, because after we get this data out of the data table, we don't retain this row name here. So I like to kind of duplicate, either if you're using an index to reference it or if you're using a name to reference it, I like to duplicate it inside of the struct in case we need that name again later. Let's make it deal 10 damage. I'm just going to punch in some arbitrary values. Let's make this a really short range tower, so we'll make it 500 range, and we'll make its fire rate, we'll make it 1. And this fire rate, how we're going to end up setting it up is this is going to be how often does it shoot. So 1 means it shoots once a second, 0.5 would mean it shoots every 0.5 seconds. So this will be how often does it shoot. We'll have this shoot once every second. So let's save it. And now if we just do save all, what we can now do is that we can go into our tower blueprint, and now let's make some code that we will use. We'll use this temporarily. Actually, yeah, let's, how do we want to do this? Let's make a custom event actually. So we're going to make a custom event, and the reason being is that I want to set up some code for testing purposes that changes what our tower is, but then we can come back later and reuse this code once we set up kind of our tower building code where we have a UI and we can like drag and drop towers into the level. So I'm going to make a custom event, and we're going to call this tower, and we'll call it like tower init, just to initialize. And then what we're going to do is we're going to take our struct, we're going to get it, because remember I made this variable a minute ago. If you didn't follow along with that, all I did was I made a new variable, I named it tower struct, and I made sure I set the variable type to equal the name of that struct that we made. So with this tower struct, we're going to break it, and now we have its information. So what we can do now is with this, we can take our tower mesh, we can get it, and that we can do set, what is it? It is going to be, so we have our tower mesh. What we want to do is we want to set this mesh. What exactly am I looking for here? Set tower mesh? No, we don't want to set the variable. There we go, set static mesh. That's what I was looking for. I don't know why it didn't pop up at first. So we're going to do set static mesh, and we're going to take our mesh. So there we go. That's what I was wondering about. So if we highlight new mesh, this is a static mesh object reference. So what we accidentally made is we made a static mesh component object reference. So let's go back to our struct. Let's go back under static mesh, and we want just a normal static mesh object reference. I think that's what I did at first, and then I had changed it. So now that we save it, but if we go back to our table, we need to reset our mesh. That is one thing that does accidentally break. So we want our bush. We have to reset that up, sadly. And now we can go back into our tower, and now this is updated, and now we can plug it in. That's great. Okay, so we hook that up. And let's see, is there anything else we want to hook up at the start? I believe we're good there. So what we can then do is let's actually set up one more tower just for purposes of visually being able to see this. So let's hit our plus button. Let's make one more tower. Let's find a good mesh for us to use. So what's a good mesh? Let's see here. Let's actually, what we're going to do, instead of finding a mesh here, let's actually go inside of our tower. Let's go inside of our viewport. Let's go and look at our static mesh. So before we use the bush, let's find a new one here. What's a good one? Maybe a chair? That could be cool. Okay, so let's use SM_chair. So I'm going to hit the magnifying glass, go back to the table, go here, and then hit our arrow. That's basically a way of copy pasting. Is if we hit the magnifying glass, it navigates to the asset, and then if we hit the arrow, it kind of like pastes that reference in there for us. So let's call our tower chair, and we'll duplicate that name there. Let's make this deal, let's make it deal less damage, and then we'll give it double the range, and then we'll make it have a slightly slower fire rate, and we'll have it shoot every 0.5 seconds. We'll make this like a bit more of like a sniper type tower, just differentiate the values. And now what we can do is that, what I said before is that I want to set up some kind of like testing code for us. What we're going to set up here is that at the start of this, what we're going to do is we are actually going to, I'm going to show you how you deal with data tables. We're going to end up deleting this code later when we end up setting up our towers in our building code, but for now, for some testing code, we're going to write some code that we'll end up deleting. So what we can do is we can do, if we type data table, you can see here we get data table row names, or what we have is we have get data table row. If we wanted to get all of the row names out of our data table, how you would do it is you would do this, you get out your row names, and then what we could type again is if we type row, or if we type data table, what is it? Oh yeah, we would have to do a for each. I guess we're not going to go through that, but there is a way, I guess we can do it real quick, but if we did like a for each, what we could do is that we could cycle through all of our rows, and then with all of our rows, we could type data table and then get data table row, and that this would be a way if we needed to go through every one of our towers. This is how you would do it. I've had to do this a good bit for my games when I have a huge data table and I need to get all of the data out. This is how you would do it. We don't need to get all of the data out. We just need to get one specific tower out. So I'm going to delete this first little bit of code, and that I'll explain how this works, is that we are basically saying, hey, we have a data table, and what I want to do is, as this node says, it says get data table row. And then what we did is we specified of our tower data table. And then you can see here, we get a pin called row name, and you can see here it auto-populated with names of our rows. So what I could do is that I could say, hey, let's get out the bush, and then you can see here we can break out the data, and then it will hand us all of this data that we set from the bush. So what we can do is that now with this, when we want to do row found, if you're ever doing this dynamically, which we'll set this up to have some like dynamic inputs here from the row name, sometimes if you input a row that doesn't exist, that's the purpose of this pin. But for us, we know what data table, what data we're grabbing out, so we're almost never going to deal with that pin. What we care about is row found, and with that, I want to call this tower initialize. Or actually, before we do that, what I really want to do is if we delete that, you can see here that we made this variable called data struct, or this tower struct. All we really need to do is do set, and then hook up this pin, and now our tower is storing this struct so that we have all the data available. So what we can do is at the beginning of our tower, we can grab which tower we want, we can store all that data inside of a variable, and then what we can do is that afterwards we just want to call tower initialize. It will then run this custom event, and that all we really want to do right now is set the static mesh. So let's try that out. So right here, we're grabbing the bush. So at the start, It's going to grab this bush row for us. We're going to take all this data, we're going to store it inside of a variable, and then we're going to call our event down here that's just going to change the static mesh over back to be the bush, because that's the row we have here. And as you can see, our tower is currently a chair, but when we hit play, our tower turns back into a bush. That's pretty cool, right? So that's kind of step one of setting this up. So now what we can do is let's actually modify our shooting code a bit. So what we have now is kind of some lackluster shooting code where it's literally just whenever something walks into our range, we just instantly shoot at it with no regards. We're going to change that up a bit. So what I want to do is I actually want to remove this code. I don't want to spawn our projectile right when we shoot. What I want to do is I want to store who are we targeting. So what I'm actually going to do is I'm going to take this pin as our AI runner, and I want to promote this to a variable, and I want to call this our target runner. Actually, let's call it, when we're spawning, I guess we can keep the naming convention. I hope I don't confuse you guys. Let's actually rename that. Let's call it tower target. Let's do that. The reason being is that inside of our tower projectile, we have a variable called target runner. I just don't want to confuse you guys by naming it the same thing twice. So we're going to make our variable called tower target. It's going to be of the variable type AI runner. And now what we want to do is that when something walks into our range, what we want to do is we're going to say, hey, this is our target. However, there's actually one more step that we need to do, and that, think about this. If we had two enemies run into our range, the first enemy would run into our range, we would cast it to AI runner, and then we would set it as our target. While that guy is inside of our range, if another runner runs inside of our range, we would just basically set the target again. We don't want to change targets. To me, the default logic of a tower is that if it has no target, it will search for a target within its range, which we'll set up in a bit. But if there's nothing within its range currently, what it will do is it will find a new target when it walks inside of its radius. And then while it has a target, it stops searching for a new target. It's going to keep targeting that same guy over and over until it's dead. And then once it's dead, it will search for a new target. So what we actually need to do here is we need to add one more piece of logic. And we're going to use one of my favorite nodes, or one of the most important nodes to me, is that it's going to be an isValid. And what I'm going to do is I'm going to take this variable of our tower target, and I'm going to type in isValid, and we're going to use this bottom one, which is a question mark, because this is basically another question that we're asking the game. We're saying, hey, this variable of tower target, there's kind of two parts to this. One, is it set to anything? If we highlight by default, if we compile this, by default, this should be set to none. Actually, it's not giving us that name none, but by default, if we click on it, its default value is none. If we never have a target and we never store our target, this is never going to be valid, right? We don't have a target, so no, that variable would not be valid. But the additional thing that it does is that say a runner comes into here, we store it as a target, we shoot it a bunch of times, and it dies. What ends up happening is that even though we technically have a reference stored to that dead target, the cool thing is that since it's dead, the game will know that, and it will come back, no, even though you have a target previously stored, that guy's dead, he is not valid. So it kind of serves two purposes for us, if that makes sense. If we never store a target, it's not going to be valid, and if the target dies while it is stored, that will also come back is not valid. So what I did here is I changed this pin. By default, it was up here on isValid. What I did is I changed it to is not valid, right? Because that's the logic we want. If we have a target and that target is valid, we don't want to set a new target. We don't want our tower to do anything. We only want to set a new target when we don't have one. And that's basically what this isValid node does for us. So what we're going to do now is we are going to change our shooting code over to event tick. So I know that our tower needs to constantly know whether or not we need to be shooting, so I need to do this on event tick, or personally there could be a different way of doing it, but personally I would probably set this up on event tick, and then further down the line, if we find a more efficient way of doing it, it should be pretty easy to copy over our code. So on event tick, I want to check, do we have a target? So we can reuse this isValid node. We can say, hey, on tick, is our target valid? So we can say isValid on our target. If we do have a target, so this variable is set to a target, to a runner, and that runner is alive, let's execute our shooting code. So what we can do is if we have a target, let's shoot the projectile. But there's something more that we need to do, right? is that what we need to do is that we need to have our firing rate. We don't want this on tick, so like 60 times a second, let's say, spawning projectiles and shooting them. We need to have some delays involved. So actually what I'm going to do is I'm going to move this shooting over to a new custom event. And the reason being is that we need to have some delays involved. I'm not a big fan of putting too many delays off tick because that actually manipulates how tick behaves. I don't want to get too much into that because I think that's more of like a trial and error experience that you need to go through to really understand it. So I actually want to do is I want to make a custom event, and I'm going to call this just simply shoot, and that after we shoot, I'm actually going to make one more custom event, and I want to call it reload. Actually, no, we don't need a new custom event for that. We'll just put it all in the same code. Let's just do that. It'll make it simpler so we have less events. So on shoot, we will spawn our projectile, and then what we will do is that we need to create one more variable, and we're going to call this reload. And that we'll set this to be a boolean because we just need this to be a binary true or false. And that what we're going to do is we are going to set reload to true. And that what we need to do is then we need to do a delay because this is going to be handling the fire rate. And that what we want to do is we want to grab our tower struct, and then remember we stored inside of our data table its firing rate. So then what we can do is we can grab out our fire rate, and remember I said this is in a sense of how often does it shoot per second, and I actually messed this up. I believe I said before that we wanted to change the chair to be 0.5. I've messed that up. Let's set the chair to be 1.5 because think about that. That is going to be what goes into our delay, right? If we put 1 second into our delay, it will shoot once every second. If we put 0.5 into our delay, it will shoot every 0.5 seconds. So I actually messed that up inside of the table. So I'm going to update that. I want the chair to shoot slower than the bush. Let's actually make it even more extreme. Let's set it to 2 seconds so that we have a very obvious difference there. It's going to be twice as slow at shooting. So I'm going to set that fire rate to be 2 so that now, depending on whether it's the bush, whether it's the chair, we can dynamically grab out our fire rate. It goes into our delay. So for our chair, it's going to spawn our projectile. We're going to set this boolean to be true because we are currently in a reload state. We're going to delay by 2 seconds, and then at the end of 2 seconds, we just need to turn reload back off to false. And then what we can do then is that we can then grab this reload and we can come back here and we can say, hey, if we have a target, are we reloading? If we say no, we are not reloading, then let's handle our shooting code. Boom, so there we go. So on tick, we're going to say, do we have a target? If we have a target, are we reloading? If we're not reloading, let's shoot. And then when we shoot, we're actually going to do one more thing. Let's actually put this reload before. Let's do that. So there we go. There might be a timing issue there. We just want to make sure that this code will never run twice before we set reload to be true. That's really what we're concerned about. We want to make sure that whenever we spawn our projectile, we just want to make sure that not another projectile squeaks out so that tick doesn't hit here and go to shoot again before we set that to be true, right? We want when it's true to not be shooting. That's just my concern there. So we're going to set our reload to be true so we don't squeeze out another projectile. We're going to spawn our projectile, we're going to delay, and then we're going to finish reloading. And then what we can actually do is let's set up a few more of our data, right? We set our damage and our range. Let's set up our range now. So on tower initialize, let's grab our target sphere, because remember this is what really handles our range for us. We need to set the radius of our sphere, right? By default, I think we have it set to 1500. Well, depending on which tower it is, we need to manipulate and dynamically change the range of this sphere. So that's what we're doing right here. So on tower initialize, we're changing the mesh to match what the data table has. Now we also need to change the radius of the sphere to also match. So let's do that. In sphere radius, let's grab out of our struct, let's grab our range, and then there we go. It's all hooked up and it's good to go. And that's the really cool part about data tables, in my opinion. We can fill this out with 1,000 towers if we wanted to, and that we just have to set up this code once, and now it's pretty much good to go. And that no matter what tower we punch in here, what data we pull out of that table, we can update the mesh, we can update the range. We don't have to make a blueprint for every single tower. And I think that's a mistake that some beginners get into, is that they don't reuse code or they don't understand how they can reuse code, they can reuse blueprints. You don't need to have a separate blueprint for every tower. Personally, that would be a nightmare doing it that way, in my opinion. I would not do that. So I like to reuse code as much as possible. So we've set up, if we look at other stuff here, our struct, we've hooked up range, we've hooked up fire rate, and we've hooked up mesh. Now let's hook up damage. So when we spawn our projectile, let's tell our projectile how much damage we want to do when it collides with the target. So if we go back to tower projectile, in the last video, we briefly set that up. We had made a float, we promoted it to a variable, and when our projectile overlapped with our target, we were applying damage, and we were applying damage of this float. Now, just like we did with our target, we want to have this pin, this target runner, we want to have that exposed to us, right? We want that to now be available to us when we spawn the projectile. So like we did before, if we go down to damage, what we want to do is we want to make it instance editable and expose it on spawn. So if we save and we compile, we come back to our projectile, we need to refresh this node to get that pin. So let's just quickly set it to none, and then type back in tower projectile, and you can see damage becomes available to us. So what I'm going to do is I'm going to drag this over. I hope no one has OCD watching these videos. I personally do not care much at all what my pins look like. Some people might give me a lot of hell for that, but I really believe if you're spending a lot of time trying to make your blueprints as pretty as possible, you're wasting your own time, in my opinion. It could be a thing if you're working a team of multiple people and someone might have to come back and edit your code. It can be very good. I really recommend commenting your code if someone else is going to be using it, and it could be worth it making it somewhat pretty. But if you need every line to be perfectly straight and all that, like I really think that you're better off doing good code than you are making something pretty. Your code does not care how pretty it is. Someone else might, but I consider that slightly a different story. So when we moved our spawning of the projectile over to this custom event, what we had to do is we unhooked this target runner off of our cast. But we stored our target inside of our tower target variable. So let's actually take our tower target, let's get it, and let's plug it right into there into our target. So now when we spawn our projectile, we're spawning it at the location of our tower, we're feeding the damage from our stored data, and we're feeding the target from our stored target. That sounds pretty cool, and I think that code is all good to go in my opinion. So what we're actually going to do now to test this code is let's actually look at our data table. How much damage were we doing? We were doing 5 damage and we were dealing 10 damage. So let's actually go to our runner and let's actually set up some health. So inside of our AI runner, if you don't have that already opened, it's just going to be under our AI in our AI runner. Let's add a variable and let's call it health. And let's make it a float. Let's save and compile. Once again, I've said it before, I'm really recommending saving a lot. That should be a very good habit. And what we want to do is some very simple math here. And when our runner receives any type of damage, what we want to do is we want to get the health of our runner, subtract it by the damage it's receiving, and that we want to then set our health to equal that amount. So we're just kind of lowering our health. And then afterwards, we just want to do a branch, and we want to check, is this health value, is it less than or equal to 0? Plug that in. If our health is less than or equal to 0, we want to kill our runner. If his health is not less than 0, then we just want him to keep going on his way. So that's what we're doing here. When our runner takes damage, we're going to take the current value of his health, subtract out how much damage we dealt to him, then set his health to be that value. Then we just want to check, basically, is this guy dead? Is he below 0, at 0 or below in his health? That's what we want to do. And then the one last thing we want to do is take the health, and let's set his default health. Let's set it to be, let's see, we said our damage was 10 and 5. Let's set his health by default. Let's just make it, let's say 25. So our chair will take 3 shots to kill, and our bush will take 5 shots. So let's try that out now. So let's see how good of our tower is at killing our runner. So we're going to hit play. We're going to eject, and let's watch our bush. Oh no, we have it set to the bush. So you can see how that dynamically set our bush. Our bush is nowhere near being in range. Let's drag that a bit closer, and now let's try that out. So let's hit play, let's eject. You can see the bush now is in range of the runner. He shoots, and he doesn't deal enough damage. Ooh, there's a good check. Look at that. So when our runner ran out of the range of our tower, we didn't stop shooting. That's an issue, so let's fix that. So, ooh, what's our error? Our error is let's see here. Attempted to access AI runner, but AI runner is pending kill. Okay. From nodes set actor location. Okay. So what this is saying is that this is saying in our projectile, when we were trying to home into our target was actually dead. So there's two things we want to fix here. We want to, one, fix the issue that we're shooting at our target outside of our tower's range, but this error specifically is that one of our projectiles was in air while a second projectile had just killed our target. So when we killed our target, we had a bullet in air, and it was just kind of left out in air, and it's just like, whoa, where am I going? You just killed the guy that I was supposed to be homing. So let's actually fix that warning first. So if we go into our projectile, what I want to do is that I want to check to make sure that our target is alive. And if you remember, how do we check to see if our target is alive? Well, we need to do a is valid check. And what we want to do is that if our target is alive and he is valid, we just want to keep shooting at him and we want to kill him. If our target is not valid, what I actually want to do is that we could do a few things here. For simplicity purposes, we could just destroy our projectile. So if our projectile was in air and a previous projectile or another tower kills our target, we could just have our projectile poof out of air, but I don't think that would be very cool looking. So what I actually want to do is that we'll actually make it home the last known location of our target. So to do that, I want to make a new variable, and let's call this last known location, last known loc, and we'll change that to be a vector. I'm going to save and compile. And that what I want to do is that while our target is alive and we're homing him, let's store this vector here. So what I want to do is I want to store this vector, and that when we store this vector, instead of, okay, actually, we're going to explain something. Whenever you have math inside of pins like this, if I left this code how it is, so we're grabbing the return value twice, this math will run twice. It's not going to run once and then we have the value and we plug the value in twice. With these type of nodes, I believe they're called impure, I believe is technically the term for it. I believe it's impure. Maybe it's the opposite. I believe these are technically impure. What happens is that this math will be run twice here. When we hit this set last known location, our code is going to do all this math and then set its value, and then we're going to hit the set actor location, and then it's going to do all this math again, and it's going to set its value. We only want to have the math to happen once, so we want it to happen here, and that we just want to get the value back out of this variable, and we're just going to use that to set the actor location. So now this math is only ran once. That's a little bit of a performance, not trick, but that's how the logic works in blueprints. So what we're doing, if we reiterate, is that on tick, while we're homing our target, we're going to say, hey, is our target still alive? If our target is alive, we're just going to store this as a last known location. So as long as our target is alive, we're going to be constantly updating this last known location, and we're going to be homing our target. But then say we're homing our target, we set its last known location, we get closer to it, and our target dies. On the next tick through, we're going to hit this is valid, and we're going to be like, oh no, our target is actually dead. And then what we want to do is that now, let's just home into the dead location of our target. So let's make ourselves a little bit more space. And now what we want to do is we want to set the actor location. And now let's see, can we reuse this code at all? I just harped about reusing code. Let me take a quick drink and look at this and see if we can reuse it. There is a way that we could reuse this code, but my issue is that we would need to be doing a select off of one of these pins, and I'm not a fan of doing selects for the sake of reusing a very small amount of code. So what I really just want to do is we're just going to copy paste this code. This is a little sloppy, I apologize, but I believe this actually saves us a little performance versus doing some selects. It is what it is. So what we're actually going to do now is we want to redo this set actor location, and now what we want to home is we want to home not a target of our target runner. Now we just want to grab this last known location, and now that's our target. So if we run through this code again, what we want to do is that while we're homing our target, we're going to check if our target is alive. If our target's alive, we're going to be storing its last known location, and then homing our target. But then on the next tick through, if we come in and we say, hey, our target's actually dead, what we're then going to do is we are then going to home the last known location of that target. So basically the deathbed of our target, we're just going to home it and collide. So say, this could be good because say we're doing like a splash projectile. Say we're shooting some huge molten rock and we want to deal a bunch of splash damage. If our target dies, we still want to land where that target last was and then explode and do some splash damage. So that's kind of the purpose of this code. So now, what that should take care of is that should take care of that error. That huge list of errors that we saw, that code should take care of it, because now we're only going to be homing our target and getting data out of this variable as long as our target is alive. Ooh, sorry for burping there. Oh, jeez. Because what was happening before is that we were trying to get data, we were trying to get the actor location of a dead actor that didn't exist in our world anymore. So the game's like, hey, whoa, slow down. You're not allowed to do that. So that's what we fixed there. So now what we can do is we can go back to our tower, and what we need to do is, if you remember, if we run our code again, what you'll see is that when our target leaves our target radius, you can see it continues shooting. So what we need to do is we need to fix that. So there's a few ways of fixing that. What we could do is we could, when we go to target our runner, where is that at? When we go to shoot at a runner, we could check the distance and make sure he's within a distance. But that's a decent bit of math. We can pretty much reuse our overlap. So we haven't used this event before, but if we click on our sphere and we right click, we can do add event, collision, and we can do add on event end overlap. So just like beginning overlap, this event runs when something leaves our sphere. So as we can get an overlap event when we enter, this is going to be as something leaves. So when something leaves our sphere, we just want to know, hey, was that our target? So as we've done before, we could grab our target that we're storing here, and we would say, hey, that person who just left the target range of our tower, that other actor, was that equal to our target? If it was equal to our target, then we want to take our target and just set it to be blank. Whenever you take a variable, especially like a reference to something, like an actor reference, if you just do set and we don't hook up this pin at all, when it hits this node, it's going to basically blank out this variable for us. It's going to clear it out for us. So that's pretty cool. So now if we run our game again, when that actor, when that target, when that runner leaves our radius, it leaves our sphere, we're going to check to see if he was that target. And since he is, we're going to set this to be blank. And remember, this is a specific actor reference to our target. So that if, say, we have multiple runners and a runner that wasn't our target leaves our radius, this is going to come back false. This will only become true, or this will only run this code to be true, when our target is equal to the actor that left our sphere. So if we run it again, we hit eject and we go backwards a little bit, you can see we shoot, and we stop shooting. Perfect. So that was good. So let's actually back this up, and let's set this to be our chair. And let's see if our chair can do enough damage. So let's go into our code. And as I said before, we're going to deal with the code that we plan on deleting later. So on event begin play, instead of making our tower a bush, for our debug code, let's just change it to be chair. So now when we hit play, instead of that being a bush, that's going to be a chair. And now our chair shoots. And oh, it doesn't deal enough damage. So let's actually move that chair, as you probably would in a tower defense. Let's let our chair have the corner so it can have more range to shoot. So now let's hit play. Now let's hit eject, and let's see now. Now does he have enough time to shoot 3 times? He shoots once. He shoots twice. And he shoots 3 times, and we kill... Oh, no, we don't kill him. So let's check our code. Why did that happen? So inside of our tower table, we are dealing damage of 5 with the chair. That is right. We're only dealing 5 damage per shot, while our runner has 25 health. Let's drop the health of our runner. Let's make it 15 health. How about that? So now our bush and our chair can kill our runner. For realistic purposes, maybe it's better to debug with values around 100 for health, because then you can deal with percents a bit better. But for our purposes, I think this is fine. So as we saw there, we shot once, we dealt 5 damage. We shot twice, dealt 5 damage. We shot a 3rd time, we homed our target, we hit him, we did our 15 damage, and we lowered his health 5, so our health is default's 15. It went down to 10, it went down to 5, and then with the 3rd one, it went down to 0, and since we are less than or equal to 0, we killed our target. So that's pretty cool. So let's actually do it one more time, and let's do it with our bush. So let's drag back, let's get it closer. It's just for example purposes. Our bush, how much damage does it do? How much damage does it do? That doesn't seem grammatically right. How much damage does our bush do? That sounds a bit better. It does 10 damage per shot, and we made our runner have 15 health. So now, this bush should only need to shoot twice to kill our target. Let's see, can he get 2 shots off? Shoots, and then 1 second later shoots again, there you go. So we have kind of like our short range high damage tower, which is our bush. It shoots a bit faster. And then we have our chair, which is its really huge radius. Shoots pretty slow, doesn't do as much damage, but it can get 3 shots off, where our bush could only get 2. So that's how we dynamically set up our towers. So let's see here, is there anything else we want to set up before moving into the next video? Let's see, we are 40 minutes in. Let's stop the video there. I did not expect this video to be that long. I thought this would be one of the shorter ones. So to recap, we set up some more logic inside of our tower. We hooked up our data tables. To do a data table, we made a new struct. We defined a few variables inside of it, and then inside of our data table, we added some new rows. We punched in our data, we renamed the row, and then inside of our tower, on begin play, we were just grabbing the values of whichever tower we wanted. We were storing its value, and then we were calling this custom event we have to set up our tower. We set the static mesh to be whichever mesh we had stored inside that data table. We changed the aggro sphere of our tower to match whatever we were shooting at. And then we handled some shooting code. Let's not go through our shooting code again because I think I really beat that one like a dead horse. And then we hooked up some more logic with our projectile, and we added health to our runner. So that recaps it for this video. In the next video, I think we'll just keep going with the towers. We'll add some more logic here, because there's actually still some holes in our shooting logic. We'll handle that. Let's start spawning some more enemies. Let's set up some multiple towers in the next video. We'll set up some multiple enemies, and we'll try and have our towers behave like a real tower defense. We'll try and fill all the holes in our logic, and that's what we will be doing in the next video, and I hope I see you guys there.